All right, here we go. Welcome to my basement. Our first asynchronous lesson here. We're going to take a look at infinite geometric series. I briefly introduced it yesterday during class on Tuesday, but yeah, let's just dive right in. Here we go. All right, yesterday we saw that it is possible, but I'm going to do it in a little bit different way to see that we can go to infinity without actually going to infinity. How is it possible? How can a sum of an infinite number of terms not be infinite? I tried to justify it yesterday. I'm going to try to show you in kind of a similar way the same idea, except instead of walking across my room, let's imagine I'm going to take a 1,000-mile road trip. I'm going to drive to, I don't know, what's 1,000 miles away? I don't know, maybe Florida. Was Florida 1,000 miles away? Someone's laughing at me right now because that's probably not even close. But I'm going to go on a 1,000-mile road trip. On the first day, I'm feeling ambitious, so I'm going to really put in some miles. I'm going to put in 500 miles. But then I'll get a little bit more tired. So on the second day, I'm going to drive only 250 miles. And then for some reason, I decide that every day I'm going to drive half the distance that I drove the day before, similar to me trying to walk out of the room yesterday. How long will it take before I travel that 100 miles? Well, if we start to map this out, first day we go 500 miles, and I would walk 500 more just to be the man who walks 1,000 miles. No, wrong, sorry, I'm getting off on a tangent on that one. Second day I drive 250 miles. My total distance driven is 750 miles. Next day is half of that. I'm all the way up to 875. Next day I pass 900 miles. I've gone a total of 937. I feel like I'm getting closer. I'll get there any day now, but the distance that I'm traveling every day is getting smaller and smaller. Every day, the distance is half of what it was the day before. So by the time I get to the 10th day, I'm only adding, well, a little bit less than a mile. So I go from 998 miles to, well, a little more than 999 miles. We're only a mile away from the destination, and every day I cut in half the distance that I'm traveling, about half a mile, about a quarter of a mile, about an eighth of a mile, getting smaller and smaller and smaller. My total distance is getting closer and closer and closer. And you can see what's happening here, that the distance I'm traveling is getting really, really, really small. The distance that I'm traveling, my total distance, is getting closer and closer and closer, just like I was getting closer and closer and closer to the door yesterday. And in reality, of course, I could just lean forward and fall into my destination. But mathematically, we will never arrive at that destination. It is possible for an infinite number of terms to add up to a finite amount. Now, we've seen the formula. The formula that we learned yesterday looks like this. The sum of the first n terms of a geometric series, first term, times 1 minus the ratio to the n, over 1 minus r. And so I want to think about what happens if that value of n gets to be really big, and I've got different types of ratios. Now, the first case is not very interesting. If my ratio is 1, well, then my second term is the same as the first, and the third term is the same as the second, and all the other terms are the same. So if I had an infinite number of terms, even if it's something like 1, 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1, and an infinite number of times, that's just going to go to infinity. I'm going to say that this diverges. I guess it would be a divergent series, which I hear is a pretty good set of books, but not that great as far as the movies go. I hope I'm not offending anyone when I say the movies aren't good. I haven't seen them. I only hear from a reliable source who lives in my house. If the ratio is bigger than 1, this is a definite divergent. It's going to get bigger. The terms are getting larger and larger and larger. And so if we've got more and more and more terms, they are just going to diverge. And not just in a boring way, but think about it, if they're all doubling. 1, 2, 4, 8, 16. Well, by the time I get to like 20 terms, we're adding millions and millions of millions, and well, it's just getting bigger and bigger and bigger. But if the ratio is less than 1, Those terms are getting smaller and smaller and smaller. And so even though I'm adding more and more and more of them, as they get smaller and smaller and smaller, the ratio is less than 1. We're going to say that this series will converge. Converge just means that we're going to get an answer. As I was trying to leave the room and walk those 20 feet, the distance that I was traveling was converging to 20 feet. The distance I'm traveling on this road trip is converging to 1,000 miles. I'll never actually get there, but that is the distance that is being approached. All right? And so if my ratio is less than 1, and I'm taking that ratio, which is less than 1, and I'm raising it to a power that is going to infinity. It's getting bigger and bigger and bigger. Try this with any decimal, 0.1, 0.9, 0.5. And if you raise it to a gigantic power, now I'm not talking about a power as small as 1,000. I'm talking about to 1,000,000 or to 1,000,000,000 or to 1,000,000,000,000. That ratio, if n goes to infinity, that ratio goes to 0. It gets smaller and smaller and smaller and smaller and smaller, which means my formula, which has this complicated 1 minus r to the n, if that r to the n is going away because it's getting so small, my formula for an infinite series actually ends up easier than for a finite series. It's easier to find the sum of an infinite number of terms than it is to find the sum of 12 terms. Because that whole 1 minus r to the n is just approaching 1. And 1 times a sub 1 is a sub 1. And there we go, a sub 1 divided by 1 minus r. It seems too good to be true. And it is. Well, it's not too good to be true. It works. It actually works. If the ratio, if my value of r is between -1 and 1, if my ratio is less than -1, we're going to have terms getting bigger and bigger, switching between positive and negative. But if it's in between -1 and 1, well, these problems actually turn out to be pretty easy. Let's try a few. Find the infinite sum. Start with 1,024, then 768. Whoops, we're subtracting 768, then we're adding, then we're subtracting, then we're adding. Well, if we find the ratio for this one, I'll take -768 divided by 1,024. Go ahead and check and make sure that the rest of these ratios are the same, but they are. -432 divided by 576, 324 divided by -432. We're going to get the same thing for all of these. We're going to get -3/4, or -0.75. And so to find the infinite sum, my formula says the infinite sum, I'll use sum with infinity as my n value. It's just the first term, 1,024, divided by 1 minus the ratio, 1 minus -3/4. Which, I guess that would be 1,024. You're going to have to excuse my mouse writing that I'm using as I make this video. 1 plus 3/4 would be the same as 4/4 plus 3/4. That's 7/4. Dividing by a fraction is the same as multiplying by a reciprocal. So I'll multiply 1,024 by 4/7. And when I plug that into my calculator, let's see, I got either 4,096/7. Boy, I think that's a number that we saw. Did we see that number yesterday? We saw a number like that, 4,096/7, which is approximately equal to, let's see, 585 point 142,857, 142,857, 142,857, 142,857. That's a repeating decimal. But I would like to see 4,096 over 7. Why not? You've got a calculator that can give that to you, or you can just work out the fraction. Anyway, there we go. So subtract, add, subtract, add. If we do that forever, the number that you get is going to approach this 585.142857142857. All right, let's try another one. Just a couple more problems for us to go through. They're all kind of the same thing. Find the sum of this infinite series. Well, I've got 1 plus 2/9 plus 4/81. The ratio in this case, I can see my numerator is being multiplied by 2. 1, 2, 4, 8. My denominator is being multiplied by 9. So multiply by 9, multiply by 9, multiply by 9. My ratio must be equal to 2/9. And so here we go. My infinite sum is the first term, 1 in this case, divided by 1 minus that ratio of 2/9. And when I plug that into my calculator, well, same thing. I'm going to do a little bit of fraction manipulation here. 1/9 minus, or sorry, 1 would be 9/9. 9/9 minus 2/9 is 7/9. And 1 divided by 7/9 would be 9/7. Or 1 and 2/7, or 1.2857, 142.857, 142.857, 142.857. But let's just call that 9/7. Interesting. We get kind of a small value for that infinite series. And then one more. This one is, I think, is pretty interesting. 0.9 plus 0.09 plus 0.009 plus 0.0009 plus etc., etc. Now, if we think about this, if you added these up, if we put these into a big column and added 0.9 plus 0.09 plus 0.009 plus, if I write this whole thing out, our answer is going to be 0.99999999999. So our answer is 0.9 repeating, but I'd like to find this infinite sum using our formula to see what 0.9 repeating is equal to. Here we go. My first term of my infinite sum is 0.9. And I've got 1 minus the ratio, 0.09 divided by 0.9, or 0.0009 divided by 0.009. Either way, you're getting 1/10. I'll call that 0.1. Well, 1 minus 0.1 is 0.9. We've got 0.9 divided by 0.9, which is 1. Well, that's interesting. I think it's interesting. 1 is the same thing as 0.9 repeating. And if that seems odd to you, or if you disagree with that, I would say that if you tell me that 0.9 repeating is not the same as 1, if you say that those are not the same value, then you're saying that if I do one minus the other, I would not get 0. And I'm going to claim that if you do one of these minus the other, you're going to get 0. They are the same number. Quick bonus question. The basketball falls from a height of 10 feet. Each time it bounces, it reaches a height that is 60% of what it was on the previous bounce. I want to find the total distance that the ball is going to travel before it comes to rest. On Schoology, I'm going to put up a little quiz for this one, just a little bonus question. If you want to try this one out, go ahead and give it a shot. But it is a bonus question for a reason. There's a little trick to this one. I'll let you think about this one and try to figure out what this answer would be. If you don't want to do this, no problem there. Just do the regular assignment. The infinite series assignment, the next assignment on the list, is due on Monday. Hey, why not? Just do it now. Get it done with today, and then you won't have to worry. You'll have something to be thankful for tomorrow. Have a wonderful day. I will see you again on, well, you'll see me on Monday for the asynchronous video, but then I'll see everyone again on Tuesday for our synchronous lesson. Have a wonderful day. Have a wonderful weekend, and I'll see you guys later. Bye-bye.